Let's try these problems in the spirit of JEE Advanced 2025, and let's give you a very raw solution for all these problems, and all these problems are generated randomly from different chapters. So it may be from sequence series, permutation, combination, probability, vectors, 3D, planes, locus, and many more. Integration, of course we can't leave it at, okay, because that's very important. So let's start with the first question. What I would suggest is first you try these questions by pausing the video by your own, and let's see how many problems you go to solve. It's the best way to gauge your preparation, because all these problems are JEE relevant and can be solved with the basic tools whatever is known to you, or in fact I can tell with the NCERT ideas. So let's start with the first problem. I is running from 0 to n minus k, and k is running from 0 to n, and ck, this guy we have to prove it's 5 to the power n. So this kind of problem is very famous. What I'll do is first I'll split 2 ka power k into 2 ka power I, and then since I is running from 0 to n minus k, so I can take everything except I separately. So let's keep apart nck 2 to the power k and put sigma over I equals 0 to n minus k and minus kci into 2 to the power I, and then sigma of k running from 0 to n. Now it's not difficult to see this term is just fitting in the binomial format, because we have something I equals 0 to alpha ci 2 ka power alpha. Okay, so these terms comes to be, it feels like ncr x to the power r and 1 to the power n minus r, because nothing is mentioned there. Okay, so what does this expansion will look like? So start from 0 goes to n minus k, so it's nothing but 2 plus 1 to the power n minus k expansion. So I hope that's clear. So this term can be written as simply 3 to the power n minus k. Now coming back to the problem, we have sigma, so the given sum becomes sigma k equals 0 to n nck 2 raised to power k times 3 raised to power n minus k, that gives 2 raised to power k into 3 raised to power minus k into 3 ka power n. So I can push 3 ka power n out, or and then we can play with the value of k. Or other way of looking at this is I can write 2 to the power k 3 ka power n minus k in this format only, because that gives is ncr x to the power r and y to the power n minus r, and that's directly expansion of 2 plus 3 to the power n, because k is running from 0 to n, hence answer is 5 to the power n. So this was a simple problem based on basics, and the idea was how clubbing can be done, and the entire idea was resting on the fact like how to take care of ncr x to the power r and y to the power n minus r. So you keep on doing in that when you get. The alternate solution of this problem can also be given from a pure combinatorics logic. So the term inside the double summation counts basically number of ways to choose from a group of n people. So let's say I have group of n person here, n people here. So what does this counts? Out of group of n people, we are, let's say, making to this joint committee of A and B, right? Such that one committee is of size k, another committee is of remaining size number of people, there is n minus k, right? Size k, or I can tell it's size I, such that I plus k is n, of course. And third committee C from among the members of both committee A and B. And the double summation then adds all these up over possible values of k and I. Hence the sum as a whole counts the number of ways to choose from n people to this joint community A and B, and the third committee C from the members of A and B, right? So we have two-stage process over here. We can also count in it in a different way. For example, for every person, let's say I have a person P1, how many choices we are having? Either it can go to no committee at all, or on committee A only, or it can go to committee B only, or it can go to committee A and C, or it can go on committees B and C. right? So since each person will have independently 5 choices, 1 2 3 4 5, and I have n such persons, hence RHS count simply 5 to the 5. So that sometimes helps you, like to count in a different ways. Okay, let's start with the second problem. So we have 4 lines, x equals -3, x equals 1, y equals 2, and y equals -4. So we can roughly draw this diagram. If A is a point in the plane, if A is some random point in the plane, it may be inside, outside, wherever it is. Suppose each of the segment from A to the lines meets perpendicular at B, C, D, E. So basically they want this perpendicular distance, so B, C, D and E, such that B is lie on L1, C is lie on L2. So you can just go with a diagram. It's not exactly what is told over here, so that you take care of. Fine. Then consider the locus of all points is such that this segment AB, AC and AD, AE are equal. And that's quite straightforward because we can directly find this length. Let's say point A is x comma y. So what is this distance from y equal to 2? So that is going to be mod y minus 2, right? Similarly, this distance from y equals -4 is mod of y minus 4, so mod y plus 4. And similarly with x, we'll have mod of x minus 1 and mod of x plus 3. Right. So according to the diagram, we can effectively tell what are these distances, and just we are going to multiply these distances to find the locus. And that's not very difficult because according to this given restriction of B lying on L1 and this, locus will be mod x plus 3 times mod 1 minus x equals mod y plus 4 times mod 2 minus y. And this is precisely the locus that I'm having. So it will open either as plus or minus signs. If I'll open as depending upon the sign, we'll get one solution as y plus 1 whole square minus x plus 1 whole square 5, and the other solution you can check by yourself is y plus 1 whole square is 13. So this curve is precisely a hyperbola and this is a circle. Okay, so locus is either hyperbola or circle over here. Let's come to the third one, and I guess this one is a bit more challenging. And it talks about the volume of a 3D structure. So pyramid kind of a structure over here. 3 pair-wise perpendicular lines, A, B, C, D, E, F have endpoints all on a sphere of unknown radius. So we have some spheres, and we have endpoints of A, B, and C, D. And let's say EF. So I'm first drawing very basic diagram of a sphere whose center is not known, and let's say radius is not known, and intersects inside the sphere at a point x. So given that and these 3 are pairwise perpendicular lines. Okay, so they have given like all these 3 lines are mutually perpendicular and they intersect inside at a point x. AX distance is known, CX distance is known, and EX distance is known. BX is also known to us. Nice. So we have these 4 distance known to us. We have to prove and find the volume of octahedron with vertices A, B, C, D, E, and F. Well, so we have 1, 2, 3, 4, 5, 6. So this will form an octahedron. The 6 vertices. We need to find this volume, also with a regress idea. So first I can tell, since AB and CD intersects at a point x, so I can use Ptolemy's theorem or power of point theorem or intersecting chord theorem. It means there is a plane which contains line AB and CD, because if I have 2 intersecting lines, let's say AB and CD, and they do intersect here over x here, so definitely there is existence of plane. So a plane will be there which contains the line C and CD and AB, right? And from this intersecting chord theorem, length AX is known. So this guy is 1, Cx is known, it's 2. Bx is 4, so that I can easily calculate dx length. So it's 1 into 4 is 2 into x, so that's going to be 2, right? So xd length is 2. Since AB and CD are perpendicular, so area of ABCD is half into AB into CD. So we can also find the area of this quadrilateral, which is in the plane. It's basically half into this base into height plus half into this base into this height. That will give half into product of its diagonals. So AB times CD, and which amounts to half into 4 plus 1, 5 times 4. So 10 is the area. So that's what I can do as of now. Right. The same argument we can give for AB EF. So now we have AB and EF, this line. So let's draw it over here. AB, point E and F. Remember, all these points, 6 points in lies on a sphere. So again, the existence of a plane is guaranteed because these two lines are intersecting. And let's say they intersect at some point x or y, whatever, because here the point y intersection is same as x over here according to the given problem statement. So now x is 1, this guy is 4, ex is 3, hence it has to be 4 by 3 by intersecting chord theorem or power of point theorem, right? Okay, by the way, some of you might wonder like why I am able to apply intersecting chord theorem just because they are in plane. Because to apply intersecting chord theorem, these 4 points must be concyclic. In fact, it is a concyclic because on this sphere, you can draw a circle passing through these 4 points. Okay, so existence of circle is guaranteed there because the quadrilateral ABCD is planar, inscribed in the circle that its plane cuts from the sphere, right? So existence of a circle AD, let's say B and C is guaranteed over here. So which circle it will guarantee? Because there will be a circle that this plane, given plane, is cutting with these 4 points. Okay, similarly here existence of circle ABCD is guaranteed. Okay, so that's why in that sense I am able to apply this Tollmy's theorem on the sphere. In fact, I am not applying on a sphere but rather on the cross section of a sphere cut by a plane which is a circle. So hence this is justified, right? And now we can tell fx value, xf is known to us 4 by 3. Now since EF is perpendicular to the plane containing ABCD, EF is perpendicular to the plane of ABCD, that is obvious because these three are mutually perpendicular, right? Okay, so EF will be perpendicular to the plane containing ABCD over here by the description of the problem. Hence octahedron is divided by that plane into two right pyramid, okay, whose base area is 10 and height is Ex because of 90 degree. Okay, so this base area is 10 and the height is nothing but Ex. So I hope you are able to visualize. And the other height on the other side is going to be Fx. And what is the area of these two pyramidal section in which this octahedron is segregated into? So it's 1 by 3 times area of base, which is 10, into height. So one height is going to be 3 over here, 1 by 3 into base into height. This base there is no need to calculate because this calculation is just for the height of pyramid, and if I add it I am getting 130 by 9, and that's the answer for the second problem. So answer for the second problem is 130 by 9, and for the first problem we have already discussed, it's 5 to the power n. Well, let's come to the next question, and it is from the integral world, your favorite one. So 0 to 1 this integrals. Now that's not very challenging as of now because there is an inbuilt hint. To get e to the power minus 1 by x, maybe I can assume 1 minus e to the power minus 1 by x as some t. So its derivative will give me 1 by x square times minus e to the power minus x dx is dt, right? So that evaluates to this quantity is minus dt divided by ta square. Okay, so indefinite integration, that's minus 1 by t. So it's simply evaluated from something to something over here. So if I assume a function f of x as 1 by 1 minus e to the power minus 1 by x, so the given integration boils down to nothing but simply f of 1 minus f of 0. Take the limit, because exactly at x equal to 0 we have to find limit x tends to 0 plus 1 by 1 minus e to the power minus 1 by x. This will simply die because e to the power minus infinity will die, so that will give you 1. So hence the answer is 1 by e minus 1 for this problem, right? So this was a easier one with the motivation of taking this as t, and the remaining will directly set in dt because of the similar nature of the expression. Let's come to the next question and see what it talks about. So prove that there is some a's of violates from mean value theorem. F is a function from real to real. Well, this is codomain. This domain is real number. If it twice differentiable on 0 1, it means the function is continuous and its derivative is also continuous, right? That's the meaning of twice differentiable function. Suppose that f0 and f dash 0 is 0, so roughly the picture will look like at 0 function dies, derivative also dies, and f1 will get 1. This is one of the possibilities of function. Prove that there is some a between this interval 0 to 1 such that at that point if I'll find the slope and I multiply this slope number with its curvature, the change in slope, I'll get to 9 by 8. Now that's not so easy to picturize. Well, so in this kind of function I have to redefine a function on which I'll apply mean value theorem, and probably that will help us. Well, now the major difficulties in this kind of problem is what function to redefine. So probably we can get a hint from f dash a into f double dash a. So since there is no sine, no cos involved, so I can probably take f of x as, let's say, x to the power k. So this derivative gives kx k minus 1. This is just a guesswork I'm doing, which probably motivates me what to take, such that there is possibility of applying mean value theorem over that function. So if the dash will be k into k minus 1 times x to the power k minus 2. And if I want their product to be 9 by 8, so which means I want k square into k minus 1 x to the power 2k minus 3 kind of a structure I evaluated at some value to be 9 by 8. Well, so what are the possibilities for k to guess? So if I exclude this part, what function should I guess to get these values? Well, I want f1 1, that's obvious, f0 is obvious, f dash 0 is 0, that's also obvious. So what if I guess k square into k minus 1 is 9 by 8? So what value will work? So it's probably 9 by 4 into 3 by 2 minus 1. That works, some power, because 9 by 4 into half is 9 by 8. So if I equate k square into k minus 1 equals 9 by 8, that gives a hint of putting k as 3 by 2. Well, so that motivates us to probably define a function g of x as f of x minus x to the power 3 by 2. I hope you got the logic of why I have defined this function, because here there is a subtle hint of if I take x to the power 3 by 2, it has some 9 by 8 connection, is derivative and double derivative. Now with this definition I can see g0 is going to be 0 and g1 is 0. So by Rawls theorem or mean value theorem, you can tell there exists some c between 0 to 1 such that g dash c must die, and g dash c, that means f dash x should be equal to 3 by 2 root x. So it means there is some c between 0 to 1, so that f dash c is 3 by 2 over root c. So that's guarantees for there exists some c belonging to 0 to 1. which means f dash c whole square equals 9 by 4 c. Now that's important because to get to f dash into f double dash, if I'll integrate, it demands f dash whole square, because that's derivative can give a connection of f c at x equal to c, which is somewhere between 0 to 1, and at x equal to 0. So let's apply mean value theorem between these two bonds. How does it works? So I'm doing over here. So there exists some a belonging to 0 to c now, such that its derivative of the function, which means 2f dash a and f double dash a, which is f dash square, a derivative at a is equal to 9 by 4. Right? That is directly from applying mean value theorem over these two intervals. And thus we got already f dash a into f double dash a is equal to 9 by 8 for some belonging to 0 to 1. So usually in this kind of JEE problems, the statement will be affirmative, because it's very difficult to tell like there does not exist something rather than there exists something. Okay, so always you try to come with some particular function whose hint will be inbuilt in the problem, right? So one hint was like defining f dash x whole square, because that possibly will give its derivative is 2 f dash f double dash, and the other hint was this 9 by 8 connection with x to the power 3 by 2. This is already previous year JEE advanced problem. So solutions I have just kept nicely. So S be a square R with the set of all points in S that are closer to the center than to any edge. So if we have a square over here and center of a square, let's just see. If R is any point which is more closer to the edge, it means this distance is lesser than this. So clearly the locus will be some region of parabola, because if R is a point whose distance from the edge and the fixed point and fixed line is equal, so we know that will be the parabola, right? So if it is closer to edge, it means we are in this region over here. So similarly, you'll get these four regions as shown in this diagram, and we have to find area of R by area of S, right? So we choose the coordinate system so that S has plus minus. So I'm taking x equals 1, x is minus 1, y equals 1, and y is minus 1. So this is a better coordinate system with a square. The parabola vertex is z. Now you can tell with 0 0 and diatrix y minus 1 forms a part of this boundary of R. All this by symmetricity, all this curve will intersect in the squares. Okay, and union of these two regions R and their intersection is a square with side length theta. So hence we can find the area of region R, and if we calculate, as you can see from this working, just we need to integrate between any one of the region, right? And if you integrate one of the region and just multiply it by 8, you will get all these four regions over here. If it is closer to the edge, then it will be this region. If it is closer to the center, then we are going to get this region, right? So here the region I am going to get is ye wala. This will be the region for the locus over here. So a square plus that extra, and that extra you can calculate by integration. Hence the ratio that we will get is 4 root 2 minus 5. 3. Since it's a standard problem, it's already done by you probably. So you can just go through the solutions by pausing it. Well, let's try. How many are there? Well, 2 more. So next one is G is a function denotes gog m times as g to the power m. And suppose G 0 to 1 to 0 to 1 is continuous. So there is some function from 0 to 1 to 0 to 1. And it's a continuous function. Right? The function might end up being constant also. It can be anything. And that there is an m such that g of m times is x, then we have to show that even g2 x is also x. So the composition of g taken 2 at a time has to be x. Now that's really nice, because first what we can do is we can show the injectivity of this function, and that's a very typical, like hallmark of these kind of problems, where you start with some conditions and try to show this injectivity. So note that if gx is gy, and this will implies g of x if I compose both them, g of y, and I can keep on doing, let's say, m times, so g of m x g m y, so that implies gx equal to x equal to y. So that shows the function g is injective for sure, right? Therefore g is injective. As injective, real valued continuous function must be strictly monotonic, since it's 1 1 and it's real valued from 0 to 1 to 0 to 1, so it must be either strictly increasing or strictly decreasing. So it must be strictly monotonic on its domain. That's obvious. So let's suppose if I take case 1 where I assume g to be increasing in 0 to 1, the way I have done this diagram, let's say over here. So if I take g to be increasing in 0 to 1, then for x belongs to 0 to 1, what I can write? X will be more than g of x, right? Okay, so suppose if x is more than g of x, so that will imply g of x, taking g on both sides, g is increasing function. So g of x will get in g2x, and keep on doing, so that will imply g of m minus 1x, composition m times gmx. And that's a contradiction, because it will show x is more than gmx, and gmx is just x according to the condition of the problem. There exists some m, so at some step, let's say m equal to 10, I'll confirm that x is more than x, which is definitely wrong. So g cannot be an increasing function, right? Or the only possibilities for this, it has to be g of x equal to x from here, identically. So hence, in fact, g2x is also x. That's the only possibility. Otherwise, you'll get contradiction. On the other hand, if g is decreasing, then g square will become increasing. So if g is decreasing function, so let's say now this time is x is greater than g of x. So g of x will be less than g of x. Again, if I'll take g, so g of x will be more than g3 of x, and we'll keep on doing it, right? So this will show like g square is an increasing function, and the above argument implies like the only way that will happen is when g2x, g of x, gog x is x. There is no other way. So in either case, anyway, we are getting g2x is x. In the first case, if it is increasing, it has to be gx equal to x. That's the only increasing function which will validate this condition. Other case, if g is decreasing, g square will be x. There is no necessity of g to be anything else, right? So that was also a good question based on basic ideas. Next is S is a set of 20 distinct integers, and set T is defined as S1 plus S2 plus S3, where S1, S2, S3 belongs to S. What is the smallest possible cardinality of T? Surprisingly, there's similar problems with S1 plus S2 with two elements was asked in JEE mains, and I think that is one of the beautiful problem JEE mains has ever asked in sequential series from arithmetic progression. So I hope you understood the problem. So let's say, for example, if I give you first 20 consecutive integers, and that is set S. So how do you define set TA? So TA contains all the members where any 3 element is randomly chosen from here and then added. So let's say if I take 1 1 1, because it can be same also, all 3. So it will give minimum element as 3. If I take 2 2 2, then we'll get 6. In fact, I can get 1 plus 1 plus 2 also, which will be 4, will also be filled in between, right? I can get 2 plus 2, 4 plus 1, 5 also. So you see, I'm able to get 3 4 5 6 continuously. The largest element I'll get is 20 plus 20 plus 20, 60. So now the question is, will I be able to get everything between 3 to 60? Every integers will be got. Answer is yes. And that's not very difficult to feel. And now my claim is, this is the smallest, like possible cardinality of this set. So for n equal to 20, what is the smallest possible cardinality of this set? Okay, so if I take 20 distinct integers. If I start with 1, I'll get 60 distinct numbers. What if I start with 0, 1 to 90? Okay, then the minimum element I get 0. Again I can get 1 because 0, 0, 1. I can get 2, 0, 1, 1. So 3 element. I can get 3 also. So we have 2. So I can get 0, 1 plus 2 is 3. So every element can we get till 57. So the answer for this will be 58. But now the claim is why I have to take AP for the minimum number of a smallest possible causality. And that proof is given over here. So suppose I have any n distinct integers. Maybe their gapping is not 1. So I have S1, S2, S3. This gapping is greater than equal to 1, greater than equal to 1. In the extreme case, the gapping will be 1 for the minimum case that we have to show. So any SI is less than SI plus 1. So let's say S1 is less than S2, or S1 is less than S3, S2 is less than S4, and so on. Now, of course, all these are distinct, okay, and distinct numbers. So it's guaranteed like I'll be able to produce, because if I'll take S1, S1, S1 and inject this, so set TA will definitely contain a number called 3S1. It will also contain a number with 3S2, S2, 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 say 3S3. And all these are distinct because all S1 to Sn are in increasing order, hence these are also strictly in increasing order. So I know the set TA is definitely containing, like n elements. And it will also contain some extra element, because you see, I'll also get element between 3S1 and 3S2. That's guaranteed. Why? Because with S1 and S2, I can create S1 plus S1 plus S2, which is 2S1 plus S2, which is definitely more than 3S1 but less than 3S2. And I'll also have an element, let's say S1 plus S2 plus S2. So it is definitely lesser than 3S2 but more than this. So given two element S1 and S2, I can definitely create, like 4 element is guaranteed. It means given n element, minimum n element is created plus extra. How many extra? So between these two I can create 2. So between every 2 gap I can get extra 2. So 2 times n minus 1. So it's guaranteed like 3n minus 2 element. That is at least set TA contains that. Now we'll show like the minimum possible element is exactly this. So it's possible exactly to attain 3n minus 1 if it is in AP. So if set contains consecutive elements, and clearly TA will be 0, 1 to 2n 3n minus 3. So the number of element in set TA is 3n minus 2. Thus minimum cardinality is 3n minus 2. For n equal to 2 is 58, which was telling. And that will happen if this is if they are in AP. Okay. Exactly a similar problem you can ask. Let's say TA is a set with S1, S2, S3, such that S1 belongs to S, S2 belongs to S, and S3 belongs to S. So under this condition, again, how many minimum number of elements will get? For example, suppose I have set A as containing 1, 2, 3. So under this condition, if I define TA now according to that rule, let's say I define set T by S1, S2 so that S1 belongs to S and S2 belongs to S. So if I take 1, so set TA, so 1 into 1 will give 1, 2 into 2 is 4, 3 into 3 is 9. So I can take combination 1 into 2 is 2, 1 into 3 is 3, right? Then 2, 3 is 6. There is no other way, right? This with this with 3, 1 is already there. So now the number of elements that I can create is 1, 2, 3, 4, 6 and 9. So we have 3, 3, 6 elements. What if I take them to be in GP, let's say 1, 2, 4. Now how many you can create? So 1 is square, 2 is square 4, 4 is square 16. Then 1 into 2 is 2, 1 into 4 is already present, 4 into 2 is 8. And now you see there is no other combination, so it's reduced. So the minimum number of elements I can create is 1, 2, 3, 4, 5 only with 3 elements. Okay, so this will give birth to GP kind of thing, right? So this was very, like a crucial problem, which shows you how to think about this. So I hope as of now you understood how to approach different kind of problem with different perspective. Let me give you some more questions, and it will be fun doing this. So let me make this session more rigorous by giving you some more And here is a problem. Let A be a square matrix. So A is a square matrix over here. And suppose there is positive integer m and n such that a ka power m is I and a ka power n is not I. Okay, it means A is not an identity matrix. Then to find determinant of that of I plus a square till a to the power m minus 1. So if there exists some mn belongs to real number, so belongs to R2, such that some power of this matrix, a square matrix, is identity, but some other power is not identity. It means this square matrix you can't take an identity matrix. Because if you take identity matrix, then it's very easy because you can add I plus I plus I and that many I. So let's say it's 10I. So if the order of a square matrix is 3, then it's 10 cube is the answer for that. Okay, but if it is not a square matrix, then we need to find the value of this, that. Now that is exciting question because the solution goes like this. How from a to the power m minus 1 I'll be able to connect a to the power m equal to I. So it feels like 1 plus x squared kind of. And remember this symbol means determinant. I want that of this matrix. Okay. So I plus, so I get that of this. I plus a square plus a cube till a to the power m minus 1 resembles like 1 plus x square. Moreover, a times I is I times a, so they are commutative. So hence, what if I multiply this with, let's say, I minus a. So let's try. So first expression is going to be 1 plus a to the power m minus 1. Minus a will give you minus a square, and the last term m minus 2 term will be minus a m minus 1, and last term will be minus a to the power m. So everything will get kicked off and I'll get to I minus a power n. So that's exciting. And this indeed has to be 0, null matrix. So now we know, let's call this matrix to be matrix B. So I know matrix B times I minus a is a null matrix. So from there, can you conclude anything about determinant of B? The answer is no, because if product of two matrices is null matrix, it might happen like neither of them is a null matrix. So one thing is guaranteed, if I'll take data on both sides, so data of B into data of I minus A is 0. So either determinant of B will be 0 or determinant of I minus A is 0, even if A is not an identity matrix. Okay, so right now I can't conclude for sure whether determinant of 0 is B 0 or not, but I'm sure out of this two matrix, one matrix must be singular. Okay, so that we can tell. So even if it is 0 0 0 1 and let's say 1 0 0 0, still is that is 0, but none of this matrix is a null matrix. So remember, if AB is 0, it does not imply A is 0 or B is 0. Even if both is non-zero, still that will be, their product can be a null matrix, right? But here is something more to this problem, because what we can see is B times, since A is not I, okay, so from here let's try B times A minus I equals null matrix. So I can tell there is a vector B, or I can tell in this way, let's say we have this 3 cross 3 matrix A. So there is some numbers x, y, z such that this is not x, y, z, right? Because A is not identity matrix. So if A were identity, then identity times x, y, z will be x, y, z. So I hope this is clear, right? So there is existence of a vector x, y, z such that if when it reacts with matrix A, it will produce something which is not x, y, z. So I am calling this x, y, z as vector B, suppose. So I know like AB is not B for some B, some non-zero B, right? So now what I can tell is, let's say, so I'll get A minus I times B is non-zero, right, for some B vector. That shows, now if I consider, let's say I minus A times B. So what I'm telling over here, so since we have B times B matrix times I minus A as null matrix, so let's multiply this matrix with XYZ, because B into A minus I minus A is anyway some matrices, so I'm multiplying it XYZ, which is I'm calling it B vector. So this must give me null vector, right? Matrix times vector, matrix times a row picture is going to be a column picture is going to be column picture, and it must be 0 0 0. Now that is exciting because B times IV minus AV is going to be 0, right? And what is B? B itself is a matrix. So let's say B1, B2, B3, B4, B4, B5, hash star, half moon, whatever. Now that I am multiplying with a non-zero vector, because IB minus AV, remember, it's non-zero because A is not identity. So what I can tell, this represents now some vector UVW, which simply is the I 0 0 0. So that is possible because now it represents, let's say if I take alpha 1 beta 1 gamma 1, alpha 2 beta 2 gamma 2, alpha 3 beta 3 gamma 3. So the dot product of these components with UVW is 0. It means UVW is perpendicular to alpha 1 beta 1 gamma 1. It's perpendicular to alpha 2 beta gamma 2. It's perpendicular to this. So now if we have a vectors which is perpendicular to, mutually perpendicular to all three vectors, so it's possible if and only if this is coplanar. Or in other words, you can say it's a system of homogeneous equation, and if it has got non-zero solution, so I'm claiming this UVW pair, which is R3 is non-zero because UVW exists. So non-zero solution will happen if and only if that of this will die. So that shows that of B must be 0 now, and hence this matrix must be a singular matrix. Hence answer for this problem is 0. The beautiful aspect of this problem is you see how interestingly I moved from the world of matrices, which was not sufficient to describe, because AV equal to 0 from here you can't get any conclusion. Okay, even if I minus A is a non-zero matrix, okay, still I can't tell like that of B has to die. That you can tell if you are sure like I minus A that is not 0. Right, so that can be done in some other way, but here my line of thinking was to think of a vector since A is not I, hence I can multiply with XYZ, and A is not identity, so it will not give XYZ, it will be distorted, it will be maybe 2x 3y and some z. So existence of order triplet XYZ is guaranteed, and then I operated through B, and soon the homogeneous system will be satisfied if and only if UVW is non-zero, which has infinitely many solutions. So if we can exist non-zero trivial solutions, that of B must die. Okay, so that was a very conceptually rich problem here to solve, and I'm sure you have enjoyed this problem. So let's finish this session with one last problem, and then put in the comment box how many problems you were able to do by yourself. So 6 to 12 root over x plus root over x plus root over x till infinite time takes. So the obvious way of solving this will be, it reminds you of class 19 question of root 2 over root 2 plus root 2. So this till infinity dx I can assume as y, and if I square I get y square minus y is x, and now with implicit differentiation it's 2y minus 1 times y dash is 1. So familiar calculus style, I can write dx as 2y minus 1 dy, and this is thanks to Leibniz to use this notation, because dy by dx is not a number, it's not a fraction, but still we can use this by the great Leibniz notation. So now we have 6 to 12 x plus root over x. You can show this is 1 to 1, it's a bijection, okay, that I'm not showing over here, which I've done in one of the videos. So directly keep these values, we'll get y times 2y minus 1 dy. And now x equal to 6 will map to, if x is 6, you can see the solution to this will get 3. 9 minus 3 is 6, and this bijection can be shown in that interval, right? And with 16, 12, we'll get 16 minus 4, so y is 4. Now why I'm not taking other values, that has been discussed in the other videos, okay? So a strong mathematical way of doing has been done. And this gives you 2 by 3y cube minus y square by 2 evaluated from 3 to 4. That gives 127 by 6 as the final answer. Of course, this problem could be done by solving y square minus. Method 2 will be y square minus y equal to x, and you can solve for the positive root because y is positive, so 1 plus 4x by 2. And now you can integrate y plus 1 plus 4x by 2 over the given interval, right? Whatever interval they have asked for. So let's say 6 to 12. And if you use the usual integration trick, this is exactly going to give you 127 by 6. So this was really a nice problem which involved basic ideas which we already know. So now one problem comes to my mind, and that's again a challenging one and beautifully created. So it's minus x to x ft dt equals f of x minus f of minus x. Okay, so you have to find a differentiable function so that this is true for all x belonging to a real number, and given f is differentiable. So if f is differentiable, RHS is differentiable, hence this is definitely an integrable function, right? And minus x to x f of t dt is not only integrable but also is continuous and differentiable. And if it is known that f0 is 2023, you can put 2024 or whatever, then you have to find all such functions. So one blind way of doing this question is you can see first feel the even and odd fragrance is coming on the function fx and f of minus x. So one blind way will to use Leibniz rule. I can differentiate, so f of x, and we'll have plus f of minus x. So put ऊपर वाला यहाँ, differentiate ऊपर वाला, minus put नीचे वाला यहाँ, differentiate minus, so minus minus will become plus. That will give you f dash x plus f dash minus x. The next step is not forced on us, but we are looking for some function that works. So it's reasonable to consider function so that f dash t equal to f of t, because it feels like if they are equal, that is one of the possible way. I'm not telling that's the only function which also. So it means I can start with this guess f of t as e to the power t, and it's easy and necessary that we can see the function that works is 2023 e to the power x. That is definitely one function which will work over here. But let's see more to this problem. So add-on is, for the first time when the question came to me, of course I went with Leibnizization, and then one of these possible solution is this. Can you give more solution? The answer is yes, infinite, because there is no further restriction. So the symmetry of the equation around x equal to 0 forces us to think about even and odd function, right? And you can quickly notice that if I take a case when f of x is even, under that conditions RHS is 0. So we have minus x to the power x f of x dx is equal to 0. And it's true for all x. Okay, it's true for all x. So what we can conclude about this feel is f of x is 2023, and that indeed works because it's an even function, and you take any values from minus x to x. Unfortunately, that's not going to give you this 0 as the answer. So 2023 is not a valid candidate, right? So what about another candidate? The simplest function that has both even odd part is probably we can, okay, and right hand side is 0 if f is odd, right? So what if f is an odd function? So if f is odd function, then we'll get left hand side 0. So I'll get 0 equals f of x and f of minus x is plus f of x, so plus 2 f of x. So that will give 2 f of x is 0, and which forces f of x to be 0. So that is indeed, it's still not work, because the only function that we'll get if f is an odd function is f of x is 0, and that's not the solution because it is violating a boundary condition of f0 is 2023. Similarly, if fx is even function, minus x to x f of x dx is 0, and that forces function to be 0 because if it is true for all, and that's again not possible because of the restriction of f0 is 2023. So I know like there will be some bit of odd function and bit of even function that can work over here, right? So that's because of the symmetricity of this problem. So the simplest function that has both even and odd part is probably we can think of a line x plus b, and if you plug this in both sides of the equation, it's possible if and only if a is equal to b. So one of the possible function is 2023x plus 2023. So that's again the other answer apart from exponential and select. Now actually in more general in a regress way, we know like any function f of x can be written as is even part and odd part. So it can be written as fex plus f of odd part of x for all x in the domain. And that's true because even part will be f of x plus f of minus x over 2, and odd part you can write as f of x minus f of minus x over 2, and if we'll add, simply we'll get this. Right. So now if I'll put this f of x is fe and fo in the original equations, you can see you'll get f dash o equals fex. It means odd part's derivative must be even part. And this shows that only the odd part of f needs to be differentiated, and that's some functions which probably you can think of is x mod x plus 2 mod x, where this part if derivative is coming out like that, right? Because x mod x will open as x square for x greater than 0, and it's minus x square for x less than 0, and if I'll differentiate, it's 2x for x greater than 0 or equal to, and minus 2x for x less than 0. It is fortunately differentiable at x equal to 0 as well, because from both sides we'll get the same answer. And what about 2 mod x? It's clearly 2x for x positive and minus 2x for x negative. So this can be packaged with 2 mod x. So you can see its odd parts derivative is even, because this is a clearly odd function. So it's some psi, if I take x mod x, then psi of minus x is minus x mod x, which is minus psi of x. So other answer for these problems is probably x mod x plus 2 mod x. So till now what I have got, we have got many classes of solutions. So to summarize, the answer is not unique. So I'll have to 2023 to the power x, or 2023x plus 2023 works, or x mod x plus mod x 2 mod x works, or put in comment box. So there will be many answers. Okay. And now if this kind of problem is asked in day, they'll possibly give you some options. And the primarily focus was to, like take away the possibilities for f of x equal to 0, because neither even nor odd function is going to satisfy this beautiful statement of the problem. So this was a Ranker series, and I hope you must have got many dimensions of problem solvings, and especially the way you think for this matrix problem, whether it's sequence series and arithmetic progression, and how you think over increasing and decreasing nature, because if input is more, like the output will also be more if it is an increasing function, and it's reverse for decreasing. And then we have seen how to think for mean value theorem, volume of parallelepiped, and this binomial theorem. Thank you. Have a good day. I'll come with more sessions like this, where certain surprise will be capsulated in the questions. Please do like and subscribe.